Welcome to the section on generative modeling. So far, we've been working with supervised machine learning models. And in supervised machine learning models, generally we have an input and an output, or better still, many inputs with their respective outputs. It's with the input output pairs that we actually train our model to learn from this input output data. Now in generative modeling, we shall do more of unsupervised machine learning, since we're going to use some input data from a certain distribution and then generate data which looks like the data from the input distribution. So as we could see right here, we have this data. We have here 4, 8, 9, we could say 7, and so on and so forth. Here we have images of people. Here we have indoor images. But one thing you may have not noticed is that these are all fake images. That is, these people don't exist. These numbers were actually generated by a model, and these indoor photos were also generated. So as we could see right here, we are dealing with models which actually take in information or data from a given distribution and try to mimic or reproduce that input distribution. Now note that we are not only limited to images. In text, we could also generate text. In sound, we could generate sound. And in fact, in many other forms of data, they can actually be generated. So supposing we have these two distributions, where right here we have the model distribution, and then here we have the actual data distribution. So this in orange is the actual data distribution, and then initially we have this model distribution. So the aim of generative models is that they actually learn from this distribution such that this P model and this P data start to look alike. And it's thanks to this that we are able to have this kind of images, or this kind of very realistic images of people who don't actually exist. But since we've been able to make our P model and our P data to look alike, our P model is able to generate this. Now recall that P data is actually the actual distribution from which data comes from, which is made of real images, while the P model is now this kind of images which are auto generated. It's the same for the MNIST and the same for this indoor images. Now the next point which I'll look at is the applications of this kind of generative models. The first or the most common application is that of image generation, where we could have this kind of images being generated. The next application is in that of image translation, where we're able to translate images from one domain to another. Now as you could see right here, we have this zebra image which is translated into a horse's domain, and then here we have this horse image which is translated into a zebra's domain. Now as you could see, when this translation is done, we also notice a change in the color of the grass. So this is to tell us that this model doesn't only translate the animal, but also even with its environment. Now here you could do summer to winter translation. That's of the same image. As you could see, summer to winter. Here we could have winter to summer translation. That's it right here. Now we could also have black and white to color translation. So we could have old photos of, say, our grandparents, and then we may like to modify them so they appear actually modern. So with this kind of models, we're able to do this kind of translations. The next is the pose estimation. So as you could see right here, we could have such generative models which are able to generate different poses even when these poses were not in the initial data set. Then another very popular application is that of face aging, where we could have the face or the current face of a person, and then we're able to generate that person's face when the person ages. Then we also have video prediction, which can be used in compression and deepfakes. So let's look at this input video. So supposing we have this kind of input videos, we are able to generate some of the face poses. So if we have this, we could have this kind of images or this kind of poses generated, and with this we could use it in video compression, where instead of sending the whole video, what we could do is we could send the first few frames, and then the remaining frames are being generated automatically on arrival. So an image or a video is sent from one, or a video is produced at the source, only some of the frames are sent to the target, and at the level of the target we generate the other frames. This particular application has already been developed by NVIDIA. Then also we have 3D object generation from 2D images. Now note that there are many other applications, so this list is far from being exhaustive. The dataset which I'll be using for our practical session is a Celeb A dataset, which you could get via this link. This dataset, as we can see, is made of more than 200,000 different celebrity faces. So we have this right up to the very first faces right here. So after the importations, we got into the data preparation. Right here we have the train directory. Notice that this directory is made of one folder, which in fact is this one. We define the byte size, we define the input dimension, and then we have our data set, which is from Keras pre-processing the image data set from directory module, which takes in the train directory. The label mode is known because here we just have only inputs, and then the image size is 64 by 64 with a byte size defined. So we could run this, and as we could see right here, we have found 202,599 files belonging to one class.